Right, if you get your notes for section 5.7, you'll find at the very beginning that there are some skills that we need to practice. I think I'm giving you two simplifying radicals and two squaring binomials to do. First two we did earlier in our class. So go ahead and see if you can remember how to simplify those two radicals. Do your factoring tree and reduce the radicals. Towards the back, not the last section, but next class. So how do we simplify the square root of, what was it, 75? When you find a pair of factors, does that stay in or come out? That comes out because you're simplifying because it's this thing. Did you get your 9 factor for that? Oh. All right, the first two should be 5 times the square root of 3 and 6 times the square root of 2. Demonstration needed on those first two? Okay, now be careful on squaring the binomials. Binomial has 2 terms to it, 2 parts, and what we had on the bell ringer did not have 2 parts to it. So you cannot just like distribute the exponent. It doesn't work that way. Okay, so what's the first one to have x plus or minus? Plus 2? Okay, so x plus 2 quantity squared is x plus 2 times x plus 2. That's what squaring means, having it there twice. Okay, now how many terms are in the first parenthesis? Is that 1 term or 2 terms? Remember the terms monomial, binomial, trinomial, different polynomials? Terms are separated by addition and subtraction. Multiplication does not. So this has 2 terms. What?
This is at the very beginning.
Of algebra. We didn't talk about it in our class really.
Oh, we did.
This would be, I don't know, I might have mentioned it sometime. But this was foiling. This is Yep. Okay, so you got 2 terms here and 2 terms here. You're going to multiply to get 4 things total. Okay, so you're multiplying x times x.
Okay.
That was your x squared. X times 2. 2x. 2 times x. Another 2x. And 2 times 2. 4. So yes, that's your FOIL. So it sounds like that's what the reminder was. The first thing's multiplied, the outer thing's multiplied, the inner thing's multiplied, and the last thing's multiplied. Lots of times those middle 2 terms we'll be able to combine. So we get x squared plus 4x plus 4. All right, there's a second example for you to try. Watch your positives and negatives. squared minus 2x plus 24, or 25 I mean. Okay, that refresh your memory a little bit? Okay, we're gonna have to square things like that in our lesson today because we're gonna be working with the Pythagorean theorem some more. And it's converse, and some of the problems will have some variables in them instead of just numbers. So a little bit of algebra practice in relation to geometry. So remind you about Pythagorean theorem. A squared plus b squared equals c squared. What sides are the a, the b, the c? C is the hypotenuse. How do you know which one that is? Across from the right angle. Yep. The a and the b are the legs, and those are identified because they form the right angle. Okay. So the legs make the right angle, and then the hypotenuse is the C. All right, so let's practice. Find the value of x, give your answer in simplest radical form. Pay attention to which sides are the legs and which are the hypotenuse. We got 6 squared plus 2 squared, I think that came out 40. We have to square root. And factoring it down, we got a pair of 2's, okay, and then a 2 and a 5 stayed. So 2 times the square root of 10. Okay. Another 1. This time find a leg. Find the value of x, simple radical form. I think when you're done with this one, grab your marker board and show me what your answer is. Simplified radical form. Don't put the X on here and then the answer.
Oh, yes.
Show me answers. Few more? It should come out 5 times the square root of 7. I think of 175 as like $1.75, so there's 7 quarters. That helps me divide it to do the factoring. We need to see some steps. Okay, how about one that's algebra related. Feel free to put it in your notes. But keep your board handy, probably put some final answers up again. And so which one's the hypotenuse? X plus 4. So leg squared plus leg squared equals hypotenuse squared. When you square the hypotenuse, put the parentheses around it. So you get x plus 4 in parentheses squared. So if you don't have the parentheses, it means something different. And I'll square it out correctly. I'll practice. Once you get it all multiplied out, then move some things around, try and get variables, terms together. Are you to the, like, x squared plus 144 equals x squared plus 8x plus 16? Okay, let's try and move some things around. What are you moving? The x squared, you want to subtract an x squared? If you subtract x squared from this side, and then from this side, notice that that drops out completely. So you end up with 144 equals 8x plus 16. Then probably subtract 16, it looks like I did at the same time. I subtracted 16. Get 128, and then divide by 8. So x is 16. So the triangle sides would have been 12, 16, and 20 to make the triangle. Question on that one? Okay. Let's do one that's kind of the same. Find the value of x, give your answer in simple radical form. And I'll look for an answer on this one on the marker boards. But you can work it on your own paper, just put the final answer on the board.
Oh, yeah.
Probably want something to go for that.
Looks like you would have gotten a -5, it should be positive, so. -2 times -2, +4. Oh, the x minus 2 is not the hypotenuse.
Okay, and as much as you can, put the cap back on your pen, on your marker, because just waiting, they're gonna dry out. Okay, on this one, you should have had it set up with x as the hypotenuse. Then when you square and combine like terms, I guess I bet you put it on the marker board, somebody should have been. I think I saw quite a few. X was 5. Alright, x was 5 in the. Now what would happen if the x squareds do not subtract out? How are you going to solve something that says like x squared plus 4x minus 10 equals 0? You do have an idea.
Oh, times.
Quadratic formula, he's saying.
What? Oh, yeah.
Under the Pythagorean theorem is the quadratic formula. That would be what you would use if you didn't have the x squareds drop out. So if you have something squared plus something that's not squared, same variable, then you're going to have to use the quadratic formula, or could use it to solve it. So you might want to write that in your notes again, just in case you need it. I'm not sure that you do, but just a reminder. If you ran out of room, let's go back to your sheet. This one says Randy is building a rectangular picture frame. He wants the ratio of the length to the width to be 3 to 1. What's that mean? Length to width is 3 to 1. Okay. Length is 3 times longer than the width. Okay. And the diagonal is to be 12 centimeters. How wide should the frame be? Draw yourself a rectangular picture frame. And we want the length to be like 3 times the width. So make it longer. Ratio of the length to the width is 3 to 1. We don't know either one of them. What can you do? Diagonal is 12. If it's a right, or if it's a rectangle, the corners are right angles. Actually, both of them would be. So basically, they're setting up a story problem with what figure? Right triangle, 2 right triangles, right. So we're going to use the Pythagorean theorem, but what are we going to use for the length and the width? We want the length to be 3 times the width. Okay, so width would be x, length would be 3x, and we would do the Pythagorean theorem to find our missing side. Yep, go ahead. Let's see if you do your algebra right. Today's kind of more of an algebra day. Are you putting parentheses around your 3x? You have to square the whole 3x. What is 3x when you square it? 3x times 3x would be 9x squared. I think I used W maybe in what I did. So we get 9w squared plus another w squared. That would be 10. You got 10x squared maybe equals 144. I think the direction said we could go to decimal. So divide each side by 10. Then you're ready to square root. So 144 divided by 10 is like 14.4. Then we need to do the square root of that. .8. Right? 144 divided by 10 is like 14.4, and then you have to do the square root. So the ratio idea, the 3-to-1 ratio might be kind of easy to think about. What if they said that they wanted the ratio to be 4 to 7? So if that problem was changed and we want the ratio of the sides to be 4 to 7, what would you use for the sides? 4x and 7x. So the ratio is 4 to 7. You're multiplying them both by a number to make it a multiple. Like maybe it's 8 and 14. Or maybe it's 12 and 21. It's numbers that would reduce to be 4 and 7. So watch for ratios popping up here and there. Okay, here's a little bit more difficult one. I've paired you up before with like the person behind you. Some of you are missing people in the rows, so your pairing's a little bit different today. So pair up looks like maybe we have a group of 3 that's in this middle row again because we're odd. Turn and discuss with your partner, how would you go about finding x in this problem?
You need that, like, the line that goes in the middle there. Or can you figure out the middle with, like,
X like that bottom line.
Maybe like something x squared equals 11.
Not that bottom.
well, you can do the whole triangle.
But you don't know that
Because you do, wait, with the bottom, you should be like 3 plus x. Or, so you go like square root, so you go square root 3 square plus 3 plus x. It's just adding square or yeah, or that's square. And then you do it that one too.
I'm going to orient my screen before I start writing. It's not writing where I'm at.
How'd you find that one side though? So that one side is. We take the small, it's all inside. You know how he was gone for like a week? He was gone for like a
Oh,
week.
yeah, it was like sick, yeah.
Yeah, but
All right, so have you figured out what to do?
The whole triangle.
Yeah.
Oh, all of a sudden there was a click, huh? So what's going on? Haley, are you explaining?
Yes. Yeah.
Okay, what do we need to do?
Find the missing side on the small triangle.
Find this. Okay, find that link first on the left-hand triangle, the small one she said. Then you can use that on the right-hand triangle to help you find x. How about using the whole triangle, the big thing, as a right triangle?
Always.
Correct, we don't know if the big one's a right triangle. So you can't do Pythagorean theorem on the great big one, but sometimes that would be an option too. Okay, so with your partner, do what we just said. Find that missing height, and then continue on to find x. Call that whatever you want.
But it's square. Because the square root of something is square root itself.
Wait, yeah, it's
And what's the square root of 34 squared?
This would be x.
34.
Correct.
The squaring and square rooting are opposite operations.
so 8 squared equals 25, so 8, that one side is 5.
So.
So,
Do you have 5 for that missing side?
Yeah.
Now do the triangle with
Are you
the
lost, Thomas?
x.
Oh gosh. Yeah, but I don't know like what to do, like.
oh, radical. Yes. Like it. Because I did decimal.
What's it simplified to be?
What's 60 on this?
And then I did my calculation.
Everybody good? 2 times 2. Get 4 like this or?
Is it 4 times the square root of 3 or 4 times the square root of 6?
First,
Okay, they were telling me 6. So is there another 2 in your factoring? Should be there.
Oh, I heard this. Yeah, it is.
Okay, so 4 times the square root of 6 was what x is.
So I have this.
Okay, before we leave this problem, I want you to find the perimeter and area of the big triangle.
Oh.
And I'll let you go to decimal. There's 10. Perimeter and area of the big triangle. There's 10.
Oh, it's a big.
Big. Okay, so on the perimeter, are you adding square root of 34, 11, and then the whole bottom is 4 square roots of 6 plus 3? So you're adding all that together for perimeter? How about 29.6? And area of a triangle, 1/2 base times height, what's the base? The 3 plus 4 square roots of 6 is the base. And then the height is 5. I'm going to do the parentheses first. Times half times 5, I get 31.99, so that rounds up to 32.0. Okay, questions? You have it written down right, Alyssa?
32 is if you rounded, right?
32, because it came out as 31.9948, blah, blah, blah. So if I go nearest 10, it's going to round up to 32.0. And I only rounded at the end. I didn't round early. So you rounded earlier? Okay. So you want to hold off rounding as far as you can or as late as you can because it's going to be more accurate that way. All right. So I think I had another example of that, but I'm going to probably skip it. So find the missing sides and then find perimeter and area is what that one was, but I just had to do that on the last problem. That one didn't say go to decimal, so you can't add square roots unless they're the same square root. Like if you have 2 square roots of 3 and 3 square roots of 3, you can add and get 5 square roots of 3. So you can only add when they're like terms, like you do with variables. All right, let's talk about Pythagorean triples. I think that's at the bottom of your page you're on in the notes. Right at the bottom, say Pythagorean triples. Okay, Pythagorean triples are a set of 3 non-zero whole numbers. We'll call them A, B, and C, such that A squared plus B squared equals C squared. So there are 3 whole numbers, or you might say positive integers, that work in the Pythagorean theorem equation, which would mean there are 3 side lengths that would always make a right triangle. If you know some Pythagorean triples, it just speeds up your work at times, because if you recognize 3, 4, 5 as a Pythagorean triple, if I give you a triangle where, a right triangle, where the legs are 3 and 4, you can quickly come up with 5 for the other side. You don't have to take the time to calculate the Pythagorean theorem because you recognize it. So these are nice to know. I'll probably ask you on a test or quiz to give me some Pythagorean triples, so maybe know 3 to 5 of them. If you know at least one, if you know 3, 4, 5 makes a Pythagorean triple, then double it. 6, 8, 10 will be a Pythagorean triple. Take it times 3, times 4, so you could make all of them off of one. But there are others. 5, 12, 13 I use quite a bit. 8, 15, and 17. 7, 24, 25. So why are those Pythagorean triples? Because 5 squared plus 12 squared is equal to 13 squared. 25 plus 144, 13 squared. Notice it calculates the same. All right, so Pythagorean triples, they're going to pop up. And in this assignment, they're going to have you find a missing side and then tell whether it's a Pythagorean triple or not. So let's try a few like that. Is there a clarifying question? Got it figured out? Okay, so let's try Find the missing side and tell if the sides form a Pythagorean triple. We've been doing a lot of Pythagorean theorem, so let me show you the missing side. Okay, there's how we would set it up. And when we solve, we get the missing side to be 50. So is there a Pythagorean triple here? 14, 48, and 50. All integers, all whole numbers, yes. That would be the, from the chart, didn't I have 7, 24, 25? Okay, so this is that times 2. Okay, how about this one? You're finding missing leg. So when they substitute in, the missing leg was 8 times the square root of 2. Is this a Pythagorean triple? Okay, no. 4, 12, and 8 square roots of 2, they're not all integers. So once you find what the missing side is, you can do a Pythagorean triple. Now if you watch out, I think 8 and 10, weren't those in, let's see, if you take 3, 4, 5 times 2, 6, 8, 10, so why wasn't the missing side here 6? Okay, because it's the hypotenuse, not one of the legs. So on 6, 8, 10, the 6 and the 8 would have been the legs. So you got to be careful that they're in the right places. So this was not a Pythagorean triple. Should be able to tell if this is going to make a Pythagorean triple even before I solve it. Okay, not going to because of the 2.4. So that's what Pythagorean triples are about. And the last thing that we'll do today then is to classify triangles by, or if I give you the sides, you can tell what kind of a triangle it's going to form. And there's 3 equations we need to look at. The first part of it is the converse of the Pythagorean theorem. Converse, remember, goes in the reverse order. Hypothesis becomes the conclusion. So what was the hypothesis of the Pythagorean theorem? What did you have to have before you can use the Pythagorean theorem? You have to have a right triangle. So the conclusion here is that there's a right triangle. So you will start with 3 side lengths. And you're going to test them in the Pythagorean theorem equation. If a squared plus b squared does equal c squared, then we know it's going to make a right triangle. What if it doesn't equal? Let me grab some of these little legs and see if we can visualize what would happen. Okay, a right triangle. And I'm just going to have to kind of talk about this last side. Okay, right triangle would be about there, and then let me grab a ruler. I need a third side that can change. Okay, so that third side would be, like I said, at that length. Okay, what if my angle between my 2 sticks gets bigger? Wouldn't the hypotenuse get longer? And so if the c gets bigger, when you square the c, and the other 2 sides haven't changed, if the c squared gets bigger, it's going to cause it to be what kind of a triangle? Obtuse, because it's pulling that angle out. And we'll go back to about a 90. Okay. If this part gets shorter, that's going to pull in the sides. C squared is going to be smaller than it was, and it's going to make an obtuse triangle. So the other part to this is the Pythagorean inequalities. In the triangle, C is the length of the longest side. If the c squared is bigger than a squared plus b squared, it's going to make an obtuse triangle. Got bigger, c got longer, so that made the angle get wider. So if the c squared is bigger, it's an obtuse triangle. If a squared, you can see in the if-then what the hypothesis would be. C squared greater than a squared plus b squared is your hypothesis. Conclusion, triangle ABC is an obtuse triangle. If c squared is smaller don't know if the picture would be the hypothesis or the conclusion. Here's your hypothesis. If c squared is greater than a squared plus b squared, if that's your hypothesis, then your conclusion is it's an obtuse triangle. If c squared is smaller than a squared plus b squared, conclusion, it's an acute triangle. Can you see how that fits? So I'm going to give you 3 lengths, and you first need to tell me, is it going to make a triangle? When did we have trouble forming a triangle? Yeah, when those little 2 legs weren't long enough. So we need to make sure that 2 sides will always add up to be more than the other side. And then, if it'll make a triangle, we're going to square all the measurements and see if c squared is bigger, smaller, or equal to a squared plus b squared. That'll tell us what kind of triangle it is. Ready to try some? And I want to see some final answers on marker boards. All right, tell if the measures can be the side lengths of a triangle. So a yes or no to start with. And if it's yes, then classify, is it an acute, obtuse, or right triangle? First see by adding, will it make a triangle? Then do the squaring and comparing to decide what kind of a triangle. All right, let's see what kind of triangle you came up with. Show me your boards. There are a little bit of variation. That one should be obtuse. Bigger or a little more acute. Was the c squared bigger or smaller? Bigger makes a bigger angle. Okay. Okay, so since the c squared was the bigger part, and I don't usually write it as c squared equals a squared plus b squared. That's the way they stated the theorem, which is why they're doing that. But I usually go a squared plus b squared. If I did it that way, then it would really say is less than c squared. If you associate less than with angles, you'd think it's an acute angle maybe. So focus on, is the c squared big or small or equal? And that'll tell you the angles. Okay. 5, 8, and 17. Alright, not even going to make a triangle. Right? So no triangles formed. Don't need to keep going. 7, 12, 16. one should have been an obtuse triangle. The c squared was bigger on that one. 11, 18, 34. I made some answers so quick because it was no. Not going to make a triangle because 11 plus 18 is only 29. What about some decimals? 3.8, 4.1, 5.2. So which one was the C value? 5.2 should have been the C value. It did make a triangle and it was, I believe, acute. Give me a thumbs up or down. Are you feeling you know what to do on those? Okay. I think we can probably end for today and talk a little bit about your cumulative test.